Okay, so we're looking at the answers for 4-4 when we're looking this over here today. And our 4-4 answers, we're just going to be making sure you guys got this understood. Okay, for in 1, okay, tell why the two triangles are congruent. Give the congruent statements, then list all the other corresponding parts of the triangles that are congruent. Okay, now these two triangles, they're going to be congruent, okay, because of side angle side. And I've got triangle K, L, J, triangle KLJ, congruent to triangle OMN. Now, this is true because of side angle side congruence. Now, they also ask about, then list all the corresponding parts of the triangles that are congruent. Okay. And it says all the other. Now, I already know that KL and MO are congruent, and I know that angle L and angle M are congruent, and I know NM and JL are congruent. Once I state that the triangles are congruent, I also know that angle K is congruent to angle O, and angle J is congruent to angle N. And I also know that last segment, segment KJ or side KJ, is congruent to side ON. Now, order matters when I'm working with these things, so make sure the corresponding parts are lined up. Now, in our proof here, given that angle ABD is congruent to angle CBD, okay, so let's get that given down. ABD is congruent to angle CBD. This is given. And I'm going to put that other angle in there too. Angle BDA is congruent to angle BDC. Now, my step 2, let's look at what I've got. Well, gosh, you know, these angles are already there. They're right there and there. I got BD congruent to itself because of reflexive. And in that order, reflexive. And I can prove the two triangles congruent. I've got triangle ABD congruent to triangle CBD because of angle side angle congruence. Now, 4-4 was all about CPCTC, which is corresponding parts of congruent triangles are congruent. And so step 4, I know those parts that I didn't list in the previous part of the proof, segment AB and segment CB are congruent because the corresponding parts of congruent triangles are congruent. And we are done with that proof. So now let's look at the next one. I know in step 1, I got OM congruent to ER, and I got ME congruent to segment RO. This is my given. And I'm looking at my picture here, and I got OE congruent to EO because reflexive. Okay, and in 3, my third step, I'm going to prove these two congruent to each other. Well, I should say I'm going to prove the triangles congruent to each other. I've got triangle OEM congruent to triangle EOR because of side, side, side congruence. And in step 4, angle M is congruent to angle R because the corresponding parts of congruent triangles are congruent. In step 4, or problem 4, I should say, I'm going to get my given, YT, congruent to YP, angle C, congruent to angle R, angle T, congruent to angle P. That's given. Now, looking at what I've got angle C and angle R congruent, angle T and angle P congruent, and I got TY here and YP. Wow, I've got the two triangles congruent already by angle, angle, side. So step 2, I've got triangle, and I'm going to go CTY. CTY is congruent to triangle RPY because of angle, angle, side congruence. Now, step 3, CT is congruent to RP because of CPCTC. And proof number 5, I know I had you guys skip this one so we could do it together, but I want you to try this before you even start looking at my solution and see what's going on. But I'm looking at this right now and I'm thinking side angle side. So turn me off, give it a try, and see what you know. Okay, welcome back. We got step 1, my given, angle SPT is congruent to angle OPT, and SP is congruent to OP, and that is given. In step 2, I got reflexive property with PT being congruent with PT, and that order doesn't switch because of the orientation of the triangles, and this is because of reflexive. Okay, step 3, I've got the two triangles congruent, like I had said previously before you turned me off, with side angle side, so I know triangle STP is congruent to triangle OTP because of side angle side congruence. Step 4, I've got angle S congruent to angle O because of CPCTC. Okay, so we got those 4 proofs completed. I hope you're understanding those. If you need to replay me, but also if you need to clarify some stuff, you're going to ask me questions. Okay, that was from the respect retreat stuff. We are in problem 6 here. And in problem 6, we're looking at the idea of this diagram to the right. This whole piece is 17 because I find out, use the diagram, TM is perpendicular BT, TM is perpendicular to BT, and TM bisects BTD. So BTD is an angle that has been bisected by TM, and TM is perpendicular. So that means by properties of bisector with angles and isosceles triangles, that BM and MD are the same measure. Okay, so half of 17 is going to be 8.5, and this is 8.5. And now we're looking at, suppose BD is 17 and AM is 5. Well, if AM is 5, I know that BA must be 3.5 and CD must also be 3.5 because this also is 5. And they're asking me the length of CD, and my length of CD happens to be 3.5. And these are from properties of perpendicular bisector and angle, isosceles triangle and angle bisector. Now in number 7, we're talking about angles. So I'm going to erase my little work here, and I'm looking at angle ATC. Angle ATC, okay, is 64 degrees. Well, I know a couple things, and they got that the measure of BTA is 16. But remember, this is a perpendicular bisector in the diagram. TM is bisecting BD, and TM bisects both angles BTD and angle ATC. So ATC has been bisected, so half of 64 is 32. And let's make that a little better. So this is 32 degrees. Maybe I'll do it this way. 32 degrees, and we'll just make it smaller. Get that out of there. So I know this is 32 degrees. So now, this is also 32 degrees. If I clone that, let's clone that thing, because we know this is also 32 degrees there. So those are both 32 degrees. And I'm told that BTA is 16. So this is 16 degrees right there. When I'm looking at that, maybe I can do it this way. 16 degrees right there. So my next thing is, let's see what they want me to find. Find angle B. They want this angle. Well, this is 90, and that's 48. So I got 48 plus 90 plus x, which is my angle B. Let's talk about it as the measure of angle B. So I've got 90 plus the measure of angle B is equal to 180. So I got 138 plus the measure of angle B equal 180. So measure of angle B is 42 degrees. Now for each pair of triangles, tell why the two triangles are congruent, give the congruent statement, then list the other corresponding parts of the triangle that are congruent. So I'm looking at 8, and I know I've got a bow tie look, and I know these two are congruent angles because of vertical angles. So I'm using vertical angles. Vertical angle theorem's helping me find that the triangles are congruent, and I know that triangle HJK, and when HJK is congruent to triangle MLK. And that is because of angle, side. Now, then list the other corresponding parts of the triangle that are congruent. Well, keep in mind, the other things that weren't used in the congruence was JK being congruent to LK, MK being congruent to HK, and angle H and angle M being congruent. Those are the other things that should have been congruent. Now, in 9, in problem 9, we're looking at this setup. I know that because of reflexive, I've got RP. Let's talk about it this way. I've got RP, segment RP congruent to segment PR because of reflexive. So now I know the triangles, and I'm going to start it at RNP is congruent and order matters. So I started RNP, so I'm going to go PQR because of side, side, side congruence. So I know that, and the other pieces that weren't stated in the congruence are the angles. Angle R, angle N, angle P, congruent to angle P, congruent to angle Q, congruent to angle R. Now that next proof, in number 10. In problem 10 here in 4.4, we're looking at the idea of vertical angles. We got a given, we got all sorts of stuff, but let's talk about this. Whenever you're given perpendicular lines, you got something called the perpendicular two-step. This perpendicular two-step, the right angles, I've got angle B, I've got angle D, okay? And I'm looking at this as right angles are given, but I have to state them. I know about perpendicular lines, and by definition, perpendicular lines, right angles are created. So I got something called the perpendicular two-step ahead of me here. So the first thing we're going to do is talk about our given. And we got the perpendicular stuff there. So I know angle CDE and angle CBA are right angles by definition of perpendicular. Now I'm talking about those two right angles being congruent in step 3, and that's because of all right angles are congruent. Okay, now vertical, I got vertical angles here, and I'm looking at those vertical angles. So I've got these two things congruent. I get to my vertical angles, and I already have those sides, and I'm going to have angle, side, angle. So let's talk about my vertical angles. I've got angle BCA congruent to angle DCE because vertical angles are congruent. BC and DC are congruent, and there should be segments above those because of given. And now I got the two triangles congruent. ABC is congruent to triangle EDC because of angle, side, angle congruence. And my last thing here in 10 is corresponding parts, CPCTC, corresponding parts of congruent triangles are congruent. Now I'm at my proof 11. I'm looking at writing down my given. Okay, so for this proof, I've got number 1. I got YA is congruent to BA, and angle B is congruent to angle Y. That's given. Now, I'm looking at my picture and I'm thinking bow tie right away. So I'm just going to go for bow tie and pull out my vertical angle theorem. Now, the look of bow tie isn't a is a look for us to know that I got to use vertical angle theorem. So I know angle ZAY is congruent to angle CAB because of vertical angle theorem. In step 3, I can prove my two triangles congruent now because of angle, side, angle. So now I'm looking at my triangle YZA being congruent to triangle, now remember YZA being congruent to triangle BCA, order matters, because of angle, side, angle. And I'm going to prove these two pieces that are the same, or congruent. They are parts of two triangles that I just proved congruent. So now I can say by corresponding parts of congruent triangles, they're congruent. See what the heck is going on there with 11 or 12 here. In 12, name the postular theorem you can use to show the triangles are congruent, then explain why the statement is true. Postular theorem. Well, here's the deal. I know they want me to prove that EA and MA are congruent. Okay, so I'm going to step through this, and I know TA is congruent to itself because reflexive. Okay, now after that, I know the two triangles are congruent to each other. Triangle ETA is congruent to triangle MTA because of side, angle, side congruence. And I know that EA and MA, those two segments, will be congruent to each other because of CPCTC. Okay. Now let's look at 12. And in 12, or 13, whichever this is, and 12 or 13, I'm looking at this being reflexive, so I know Jn is congruent to Jn. Now I didn't change that because they're in the right order. This is reflexive. And now I know the two triangles, triangle JUN is congruent to triangle JEN because of side, side, side congruence. Okay, and angle U is congruent to angle E because of CPCTC. What is the side opposite ABC? We're looking through this one. Okay, so we're looking at segment AC. So I've got ABC, so AC is opposite that. What's the angle opposite side AB? The angle opposite AB is angle C. What is the angle opposite BC, side BC? And that's angle A. And now I'm supposed to find the value of X. Remember, the value of X, the X is equal to the two remote interiors, 75 plus 30. So X is equal to 105. Now, this next one. List all the pairs of corresponding angles. Corresponding angles, I've got angle 1 and angle 5, and angle 2 and angle 6. And I've got angle 4 and angle 8, and angle 3 and angle 7. List all the pairs of alternate interior angles. I've got angle 4. Remember, angle 4 and angle 6 are alternate interiors, and angle 6, and angle 5 and angle 3 are alternate interiors, angle 5 and angle 3. List all the pairs of alternate exterior angles. My alternate exteriors are 1 and 7 and 2 and 8. So angle 1 and angle 7 and angle 2 and angle 8. Now list all the pairs of same side interiors. So angle 4 and angle 5. And then I've got angle 3 and angle 6. And then in 22 here, list all the pairs of vertical angles. And I've got vertical angles. I've got angle 1 and angle 3. And angle 2 and angle 4. Angle 5 and angle 7. And angle 8 and angle 6. Well, last part of this, 23, the coordinates of point T are 1 and 12. The midpoint is ST is 5, 8. Find the coordinates of the point S. So I've got T is 1 and 12. I've got S, they're looking for, I've got the midpoint there of TS. So my midpoint is 5, negative 8. And they want S. Now, this is something that we've talked about with how far we've gone. This is down 20. So I've subtracted 20. I've added 4 over here. Subtracting this is going to be negative 28. And this is going to be 9. So when we look at those, because they're halfways. Now, find the coordinates of the midpoint HX when H and X are there. So midpoint, okay, is equal to x2 plus x1 over 2, y2 plus y1 over 2. So negative 1 plus 7 over 2, and 3 plus negative 1 over 2. So I've got 6 divided by 2 is 3, and I've got 2 divided by 2 is 1. That's my midpoint. Okay, that should be the corrections that we've had for 4-4. Thanks for participating.